This is the second video about the Avogadro constant. If you're a bit shaky on the Avogadro constant, or if you're not quite sure about it, can I recommend you go back a couple of pages in the workbook and have a look at those questions again. There are two videos that are worthwhile looking at before you start on this one if you're a bit shaky. The first one is Avogadro constant video 1. And the second one is about the moles equation, because we're going to use what we learnt in both those videos and combine them to these questions. These questions are where they start to get really quite tasty for GCSE, and we're certainly accessing the grades 8 to 9 with questions like this. So they're meant to be hard, but once you know how to do them, of course, they're quite straightforward, and I think everybody can get there with a little bit of time and patience. So let's have a go. So the question, can we use the Avogadro constant? And we're given the Avogadro constant here, 6.02 times 10 to the 23. So we don't have to remember that number. It's always given to us. Can we use the Avogadro constant and the mole equation? Notice we're not given the mole equation. We have to learn that, and we stated that several times in the last video. Now the moles equation is right at the top of this page where we looked at it in that moles equation video. We've got our moles formula here. Moles equals mass divided by formula mass, and we have to learn that. That's absolutely vital. So can we use the Avogadro constant moles equation to work out the number of particles present in 90 grams of water? So this would be the number of molecules present in 90 grams of water. So this is a two-stage calculation, and that's why I told you it was ideal if you've just watched or just revised those last two bits. The first one is the moles equation. So let's write that out. Always write out the moles equation. Moles equals mass, okay, divided by formula mass. We have to learn that. We've got 90 grams of water, that's the mass, that'll be the 90. We need to work out the formula mass of water. Now there's two hydrogens in water and one oxygen. The hydrogen's got an atomic mass of 1, so it's going to be 1 plus 16. Okay, because there's two hydrogens, so two ones, and the one oxygen is 16. Okay, and the mass is going to be on top. Moles equals mass divided by formula mass. 90 grams is the mass. And that 18, that's going to be 18, we need to work that out first, is going to be on the bottom. So that's going to be 90 divided by 18, and that's going to be 5 moles. Okay, so that's stage 1 of the calculation. Even if that's as far as you get in a test or an exam, that's worth credit. Okay, so that's worth marks. I think everybody can get there. Remember, we don't have to get all the marks, we just have to get 75% of them to get a grade 9 or thereabouts. So that's the first part. Now the second part, I told you it helped if you watched the Avogadro constant video 1. Now this is what we filled out in the Avogadro constant video 1. And we had this formula here. The number of moles multiplied by the constant equals the number of molecules. And that's what we need to find out this time. Okay, it's the number of moles. So we now need to take the number of moles. So I'm just going to put number like that of moles multiplied by the constant. And that is going to be the number of molecules at the end. Okay, and that's what we're trying to find out. So the number of moles is 5. The Avogadro constant is always given for us, 6.02 times 10 to the 23, 6.02 times 10 to the 23. Okay, and now we need to put that in a calculator. Now remember, putting this number in the calculator here, this is not the multiply button. Okay, so let's just quickly do the keystrokes down here. Okay, you don't have to write this out like this, I'm just doing this to help you. Okay, so every button I press on a calculator, I'm putting a square around it. Okay, so that's going to be the multiply for that there. Okay, that's going to be 6, that's going to be the decimal point, so that's the button for the decimal point, for that decimal point there. Next one is O, and next one, unsurprisingly, is 2. Now the one where people go wrong, okay, that is going to be the times 10 to the x button. Okay, I'll show you that in a moment. Then it's going to be 2, then it's going to be 3 for the 23, and then it's going to be equals. Okay, so that's the key set of keystrokes in the calculator we have to press. Let's get this in here now and see if we can get an answer out for that. Okay, there's a bit of a glare on that screen, haven't we? So let's see if we can just tilt that out of the way, it might be a bit better. Getting a bit dark, so I had to put the light on here. This will be the last video of the night. Right, so we've got 5 times 6.02, 6.02. Now this times 10 to the x button, that's that one down there, times 10 to the x. It may be labelled something different on your calculator. It may be labelled EXP. It's more unusual nowadays. If you're using an iPhone to do this, don't. You can't take an iPhone into the exam. But if you're using an iPhone to do it, this button is called EE. So it's called different things on different calculators, and you have to learn how to use the calculator you're going to take into the exam. Okay, so times 10 to the x, that's that button there. Now 2, 3 and equals, 2, 3 and equals. 3.01 times 10 to the 24, and that is our answer. 3.01 times 10 to the 24. Okay, right. The next questions. 2, 3, 4 and 5, all pretty similar to be honest. Okay, so I'm not going to go through those. Same method, you can do those in your own. But what I will do is I'll give you an approximate answer for each of them. It's not the exact answer. Okay, so if you come and show me in lessons that you've worked hard and got these answers, I'm not going to believe you because I want the exact answer. That one, number 2, is approximately 2.5 times 10 to the 24. It's not exact. You can do that better for me. This one here is about 1.5, approximately 1.5 times 10 to the 23. So I want to know the exact answer. I want to see all you working. Okay, this one down, number 4 here is going to be about 9 times 10 to the 24. Okay, now when you come to write that out, okay, you may think it says 23, but look carefully, it's going to be 24. It's approximate though, I want to know the exact, please. And that one down here is going to start 7.5 times 10 to the, well, I'm not going to tell you what it is, you need to figure that one out yourself. And it's not 7.5 either, that's about. Okay, so they're the approximate answers. You'll know you've got them right if you're getting in that sort of ballpark. Okay, so next page. Can we use the Avogadro constant and the mole equation to work out the mass in grams of each of the following? Okay, so this again builds on what we were doing last time, last 2 videos. First off, we need to work out how many moles we've got. We've got a number of atoms. We need to, sorry, I should say number of molecules, shouldn't it? I've changed that on the version that you are working on in your books. Okay. So we've got this many molecules of chlorine, Cl2. So we need to work out how many moles we've got. Okay, so that's easy if we know how. If we don't, it's pretty much impossible. But we used this formula last time, and it was down here. Let's see if we can find it for you. Okay, so it's in the last video. It was the time for the mole page. It was question number 4. We had number of particles divided by the constant. That's the formula we're using to tell us the number of moles. Okay, so we've got number of molecules. Divided by the constant. That's going to tell us how many moles there are, equals moles. Okay, so we've got 1.806. We've got 1.806 times 10 to the 23. Divided by the constant now, we're always given the constant, 6.02 times 10 to the 23. Now that's quite a mouthful to put in the calculator. Let's do it together, just check we can do that correctly. Okay, so we've got 1.806, 1.806. Now remember, this is the most important button, times 10 to the x. 23, now we're going to do divide. Okay, we're dividing. Divided by 6.02, now times 10 to the x, times 10 to the x, 23, equals 0.3. We've got 0.3 of a mole. Okay, so if you got that far without the video, you're doing pretty well, to be honest. We've got 0.3 of a mole of chlorine molecules. Okay, now all we've got to do is rearrange the moles equation to make mass a subject. Put finger over mass. Mass equals moles times mR. Okay, so let's write that out. Mass equals moles times mR. mR is the formula mass. Okay, and the moles we've got there, so that's going to be 0.3 multiplied by, which is Cl2, so it's 2 chlorine atoms. 1 chlorine atom is 35.5, so 2 is going to be 35.5 plus 35.5 Okay, so 0.3, that's going to work out to be 71. 0.3 times 71. Okay, let's put that back into a calculator. 0.3 times 71 equals 21.3. Now this is a mass, so it's going to be grams. Equals 21.3 grams. Okay, these ones all very similar. Let's give you some approximate answers for those. Okay, this one here, number 2, is going to be approximately 7 grams. Not exactly, you need to figure that one out. The next one is going to be, well, it's going to be between 0.1 and 0.5 grams. Okay, somewhere between that. Number 4 is going to be, this one here is going to be somewhere between 900 and 1,000 grams. So you'll know if you've got that right. And number 5, I'm going to leave you to do all on your own. Okay. Now, these ones. Okay. Questions like this, because a question like this about hydrogen, I think in the 2019 paper? I think it was the first year of this new specification. It was horrible. Okay, only the really top candidates got it right. In fact, plenty of candidates that got grade 9s that didn't get it right. Okay, so to do these, they're quite straightforward if you've got your head around the Avogadro constant. But to be honest, they're not really that straightforward. Okay, but we can certainly do them. So what is the mass in grams of one magnesium atom? Oh, hold on a second. Magnesium atoms. You can fit billions and billions of magnesium atoms on that full stop, on that decimal point between that 6 and that 0. So the answer is going to be virtually nothing. It's going to be massively tiny. Okay, and so let's just try and unpick again what the Avogadro constant is. Okay, well here's magnesium on the periodic table. It's got an atomic mass of 24. Now what Avogadro said is if you have the mole, 6.02 times 10 to the 23, particles of, or atoms of magnesium, that 24 becomes 24 grams exactly. So if we have 6.02 times 10 to the 23 atoms of magnesium, we've got 24 grams. So now we've got some data. Okay, 24 is the atomic mass of magnesium. Now if we have 6.02 times 10 to the 23 atoms, we've got 24 grams. So let's take the 24 grams and divide it by the 6.02 times 10 to the 23 constant there. The number of atoms that's needed to give us that 24 grams. And that's going to be a really small answer. Okay, so 24 divided by 6.02 times 10 to the x, 23, equals, okay, we've got an answer there, 3.98671 times 10 to the minus 23. Okay, so we can probably round that, can't we, just 4. Okay, because all these numbers are going to round up. So let's just say 4 equals 4 times 10 to the minus 23 of a gram. Okay, so in other words, 22 zeros and then a 4 after a decimal point. So a fraction of a gram, incredibly light. Okay, so questions 2 and 3, pretty much identical. Okay, but there's a nasty sting here. Have you spotted it? So this one says, what is the mass in grams of one oxygen atom? Well, that's the same as that, isn't it? Same sort of question. We just put 16 up there, divided by 6.02 times 10 to the 23. You can have a go at that. And the next question, what is the mass in grams of one oxygen molecule? Okay, so an oxygen atom is just one, but the oxygen molecule is the O2 molecule. So it's not going to be 16 on the top. It would be 2 16s, 32 on the top. It's essential here we know the difference between a molecule and an atom. Okay, as I said, these are pretty nasty. Good luck with those, and don't forget to show me if you need, or ask me if you need any extra help. They are difficult, these.